On this first one, they're talking about a sampling distribution, and you're taking a sample of size 16, and they want to know if the sampling distribution is approximately normal. For it to be normal, either the sample has to be more than 30 CLT, or you need a normal population. So for this one, you would need the normal population because your sample's so small. I don't think 22 is going to be on there, but I'm going to do it with you to show you just in case. But here's what we're going to do with 22. There's my z-score. My mean is 72, and my standard deviation is 6, but it's a sample of size 81. So it's 6 over root 81, or 6/9. You can simplify that if you want, but it will not matter. What my z-score is, my z is going to be x, and my sample mean was 73, so that's my x. Mu is 72 divided by 6/9. I'm going to do, on the little calculator, I'm going to do 73 minus 72 equals, divided by, and put your 6/9 in parentheses, 6 over 9. And my answer is 1.5. And like I said, I don't think that will be on there because it's too hard to type. 23, if the sample size is increased, what is the effect on the standard deviation of the sampling distribution? And the mean of the sampling distribution is mu. The standard deviation, or standard error, is the sigma over root n. And if you increase n, so if you make your sample size bigger, you decrease this. So it decreases because you're dividing by a bigger number. And if you're not sure, type in a number and divide it by something, and then divide it by something bigger, and you'll see that the number, your original number, decreases. This is a confidence interval. And remember, we talked about anything that says chance or sample is not the answer. So if you look at the last two, it's neither of those. It's one of the first two. And be real careful, because they're talking about not all electronics industry CEOs, but they're talking about the mean salary of all. So make sure you pick the one that has mean. This one is about milkshakes, and the confidence interval is 490 to 560. Look at your questions. On average, milkshakes sold at the fast food restaurant have more than 500 calories. Some of those have less. Have more than 450. That looks good. All of them have more than 450. The next one, less than 475. They don't all have less than 475. None of them do. Have less than 525. They don't all have less than 525. So that was the best answer. When you're doing a confidence interval and you go from 95% confidence to 99% confidence, you increase the margin of error. Like, in order to decrease the margin of error, usually it goes from 99 to 95 to decrease it. But if you did these two intervals, they're not going to be the same width. You know that the 99 is going to be wider. This is an easy one, but be careful. You've got to make HO and H1, and it says you're going to do a hypothesis test, and you want to see if the mean screen time for all teens is more than 7 hours per day. So you know that the answer is either the first one or the last one, because that's the only one with H1 more than 7. And it has to be the first one, because HO and H1 we know has to match. That 7.37 is your sample. Don't let that trick you. On this one, we want to test the claim that the population mean differs from 19. All right, so I know it's the second or the third one, because it's got to have 19 in it. Differs from 19, it has to be the third one. The sample mean is 17. Don't let that throw you off. You would reject HO if the p-value is low, if the p-value is less than the alpha level. And when you're looking for the most evidence, you want the smallest p. So the smallest p-value would be that one.